machine learning are transforming the way that we do business. But as we become more dependent on this cutting edge technology, we need to consider how to build positive outcomes while preventing unexpected results. To talk more about this emerging responsible machine learning, please welcome our esteemed panel. We have Willem, we have Hannah Wallach, and we have Manoush Sameki. Thank you so much all for joining on Build Live.
Thank you.
Thank you for having us.
Of course. So I don't want to introduce you because if I was introducing you, it would just be each one of these people is amazing, and that's just all you need to know. But what I'd like you to do is each introduce yourself. So Willem, do you want to go first?
Sure, yeah. I'm Willem Meijns. I'm from the Netherlands. I work as a technology advocate for InfoSupport, and I typically help customers get started with AI, machine learning, data platforms, that sort of stuff. That's what I like. And in my spare time, I run the Global AI Community, which is a very, very large group of people across the world that are doing all sorts of cool things around AI, trying to teach each other about machine learning, about AI stuff. And yeah, generally coding. That's what I love.
Fantastic. And Hannah, can you introduce yourself?
Yeah, absolutely. Hey, everyone. I'm Hannah Wallach. I'm a senior principal researcher in Microsoft Research New York. I'm a machine learning researcher by training. I've been doing machine learning for about 20 years now, so way before this stuff was fashionable. And nowadays, most of my work focuses on issues of fairness, intelligibility, stuff like that, as they relate to AI and machine learning. I run Microsoft's internal Ether working group on fairness. And I'm also a contributor to the FairLearn toolkit that was released this week.
Fantastic, and we'll get to that very, very shortly. But first, Manoush, can you introduce yourself for us as well?
Absolutely. My name is Manoush Sameki. I'm from Microsoft Boston, or really Cambridge, and I'm a senior program manager driving the product efforts behind two of our open source responsible AI offerings, Interpret ML and FairLearn.
Fantastic. So yeah, for my descriptions, we have an absolute community hero in Willem. Hannah just blows me away every time I see her speak about the amazing stuff she does around ethics in AI. And Manoush is obviously pulling research into actual product. So I just want to thank everyone for joining us. We have a little bit more time than normal to quiz you all or hear your perspectives on responsible ML. So I would love to start, because we briefly mentioned it in some of the introductions, about some of the announcements that have happened at Build. So Manoush, can you tell us a little bit more about responsible ML, but also the part you took from the Azure Machine Learning team?
Yeah, absolutely. So as you mentioned, we have had some major announcement in this conference, which is pretty exciting. We do have two particular open source toolkit, Interpret ML and FairLearn. One of them, the first one, is for helping you understand your models better. How did my model make its decision? What factors went into the decisions of my model? And that can be on the overall or global level of overall how this model is making its predictions, or on the individual level. So for this particular person, what factors went into his or her loan getting rejected? Beside that, we have a fairness assessment and unfairness mitigation toolkit that was also announced in this conference that is called FairLearn, which has been based on the awesome research from Hannah and her team, Miro Dudik. And basically that particular one is due to the fact that we understand that AI systems can behave unfairly, and there are multiple types of harms that can arise. And this particular toolkit is to enable you to really understand and assess the unfairness that is happening in your model, and of course, then a set of mitigation algorithms to mitigate that unfairness. Now, we were aware that lack of access to actual practical tools in order to develop and deploy responsibly, basically artificial intelligence responsibly, has been number one blocker for a lot of executives, a lot of data scientists, a lot of machine learning developers to really get AI right. And that's why, beside releasing them in the open so that everyone can get benefit of them and everyone can join the effort, co-develop with us. We also integrated it with Azure Machine Learning because we only want the best for all of our Azure clients to have access to this state-of-the-art set of tools to really put a lot of control and a lot of understanding, analyzing around their machine learning lifecycle.
I know. I was going to say, I love that it's in Azure Machine Learning. I love that it's in the SDK. And I just haven't even had the chance at the moment to go in there and take a look. So I'm pretty excited. Starting next week's first thing I'm going to be doing. But it's really, really interesting to see that it's kind of coming out of research and then straight into our products. And big fan of Azure Machine Learning. So love that it's in there. And I guess actually that probably segues us very, very nicely to Hannah. Hannah, you mentioned you've been kind of working on this open source framework, FairLearn. You also have a much wider scope of kind of ethics and fairness, accountability, transparency, and ethics in your research space. Can you tell us a little bit about how the toolkit fits in the space? And I'm assuming it's not a one and done thing. There's more to it than this.
Yeah, that's right. Absolutely. I'd love to talk a bit about this. So one of the things that we've seen over the past few years is this growing realization that, AI systems really can end up discriminating or disadvantaging already disadvantaged groups. And in order to sort of really engage with these issues, we have to approach them not just from a software perspective, from a technical perspective, but from a broader socio-technical perspective. The reason why AI systems can behave unfairly is, yes, oftentimes because of the data or decisions that have made during the development and deployment lifecycle, leading to particular characteristics of models or systems as a whole. But ultimately, it's when these systems interact with the real world and the people who are using them or whose lives are impacted by them that we start to see that kind of unfair behavior. And of course, because we're dealing with this topic that is fundamentally socio-technical, this means that we have to draw on this wider range of tools and resources than simply software. So yes, FairLearn is incredibly useful for really understanding particular types of fairness issues with machine learning models, specifically issues around sort of allocation of resources or opportunities, and also issues around quality of service. So does my machine learning system perform as well for one group as it does for another? But when we start sort of digging into these kinds of issues and how they affect people's lives and maybe different ways that we want to try and mitigate them throughout development and deployment, we have to use other things as well as software tools. One of the things, for example, that my team has been working on is an AI fairness checklist. And again, I don't mean to imply that this is sort of a one-size-fits-all, just use this checklist and you'll be done. And in fact, many of the items on this checklist are much more intended to provoke conversations and discussions and really to make sure that teams are sort of engaging with this space, even though it is difficult and maybe outside the realm of things that technologists normally think about. But we think that all of these resources together, so things like the checklist, things like FairLearn, things like sort of broader even education in this space and helping people think about these kinds of issues from day one of development is really the first step towards making progress. Another way to put all this is that when we're thinking about issues like fairness, it's a bit of a culture change, moving away from the traditional sort of tech first, can I do this? Will it work? All of that kind of stuff mentality, and moving to more of a people first mentality. So if I do this, what will be the impacts on people, on their lives, on society as a whole? And of course, in order to make that kind of culture change, you need a wide variety of resources, of tools, of materials, and so on and so forth.
That's amazing. And I know you've been doing work in this for quite a while, and so it's super exciting to kind of hear both the collaboration into engineering, but also that kind of statement of we're all on this learning journey, right? Like the toolkit is going to help us as those who are building models to hopefully rectify those mistakes. But I love when you're saying like this got to be designed in, this got to be talked about right from the start, just like we say about security, right?
Exactly. It's a lot like security and privacy in that it's not something, fairness is not something that can be left as an afterthought. It is something that has to happen from day one. And so it's super exciting to see Microsoft firstly committing to this space, and secondly to roll out a variety of different tools and resources to help developers really prioritize this. One of our ultimate goals for Fair Learn is not to just have it sort of focus on assessment. So we have this assessment dashboard component, and then also this mitigation component, these mitigation algorithms, but to really expand this out into other resources as well, like domain-specific guides for when and when not you might want to use particular fairness metrics, and also for when you might want to use particular mitigation algorithms. We also want to see this expand to sort of handle other materials to help people think about other types of unfairness beyond just these allocation issues or quality of service issues. So here, for example, we're really interested in moving to things like stereotyping and denigration. How can we help our developers prioritize those? They're much more socio-technical kinds of, unfairness than allocation or quality of service, which can be, they're still socio-technical, but you can often get more of a handle on them from that technical perspective. But ultimately, we want to be building out to really consider that broader space and help developers sort of navigate that landscape together. It's also really exciting to see all this coming over from research as well. As a researcher myself, it's just super exciting to see when things happen in the research world and then actually make it out to the tools and the resources that we're putting out there for developers.
I was going to say, it feels like we're hearing this more and more. In fact, I think 3 times today we've spoken to people from Microsoft Research because they've so closely collaborated with Azure, with Microsoft 365, whatever it is. So it is fascinating to see, like, this literally is cutting edge. And immediately we're like, where can it be used, right?
It's a lot more satisfying, I have to say, than just writing yet another academic paper. It's really nice to see this stuff actually out in the world and people engaging with it and using it and having it make a difference.
That's amazing. Don't play down the academic papers. I bet you've got a million of them. So, but cool. Thank you so much, Hannah, for that initial insight in that space. I wanted to turn the conversation a little bit to Willem. Willem, my bestie from the Global AI community. So Willem leads the Global AI community. For those who don't know, globalai.community, go there. If you want to learn about AI, this is the community to be a part of. It is so exciting, and we work super close with Willem and his team. But Willem, what I wanted to know was you actually got a chance just before Build to have a look at these technologies that Manoush and Hannah are talking about. Can you tell us a little bit about what you found?
Yeah, so I got a chance to try out Fair Learn a few weeks before Build. Back then it didn't have a lot of documentation, so for me it was actually reading the papers that Hannah and others wrote. So for me, yeah, that's the kind of thing that I like to do. I like to try new stuff, and especially in the field of AI, it's very important that you learn to read those papers because they give valuable insights on how to use particular tools. Fair Learn, it's the same. So I started reading the paper, started trying it out, and very quickly I found one of my models was sort of unfair towards female customers. And it wasn't immediately visible to me because I was very careful. I tried to exclude features like gender, like ethnicity, age, all that stuff. I tried to remove from my training set because I knew they would be sensitive. There would be something that my model would pick up. But despite the fact that I removed them, my model still picked those features up. And that's kind of funny when you try to do this kind of thing. Fairness is not something that you can pick up right off the bat. You know upfront whether your model is going to be fair. You have to train it first and then measure its fairness using Fair Learn and then go back and try to improve that. So it was kind of fun to do that.
That's amazing. And obviously there is some documentation out there. Did you use documentation to kind of get started with that tech?
Yeah, so right now the website is up and running. So there's a user guide that takes you through getting started with a couple of notebooks that explain step by step what you have to do to measure fairness and how to improve it afterwards. And they also include a very extensive description of the API. So once you've worked through those notebooks, you have sort of a sense of where you're going. But afterwards, the API will help you truly understand how to select certain features or what all the options mean. It's really great that they've been able to put up this website so quickly.
Fantastic. And obviously with there's other members, right, of your sort of main part of the global AI community that got a chance to cover other technologies. Is there somewhere we can send our amazing audience to go and read about them?
I don't have the link handy at the moment, but I'm pretty sure we can share the link afterwards. So we've got a couple of blog posts online that explain all the responsible AI initiatives. We've actually looked at white noise, the differential privacy tool that Microsoft announced. We've looked at Seal. That's actually a tool that allows you to train models without actually seeing the data. That's also pretty cool and pretty complicated. I've learned from Sami, who's been trying this out. And we've looked at stuff around explainers as well, specifically into NLP jobs, trying to figure out why is my model predicting a certain category for an email or a document or something like that. It's pretty awesome. And I'm pretty sure we can send a link afterwards.
That's fantastic. I was going to say we do have comments to the right, so maybe we could pop there on mybuild.microsoft.com just afterwards and spam them with a few links just there. We have a really interesting poll going at the moment from our audience, and it is fascinating to see all of the different types of systems that people are building with machine learning. So we've got sort of pure prediction, so maybe more classical modeling. We've got quite a lot in the area of image, a little bit in speech, and personal assistance is an interesting one. I guess it's been big at Build with chatbots as well, and actually thinking about that low code, no code aspect. So yeah, I just wanted to share that with you guys very, very quickly. And then could we switch back to Manoush for a second actually here? So I had a chance to, because Interpret ML is a GitHub repository, right? All of this stuff is open source, it's available on GitHub. I had a chance kind of at the start of the year to dive in a little. It's quite complex, so brace yourself, everyone. But can you tell us a little bit more about it? Maybe I should have just come straight to you.
Yes. So basically, when you land on Interpret ML.org under GitHub, you'll see a few repositories underneath that. The main one is Interpret. So Interpret holds a collection of what we call glass box models, or in very simple words, interpretable models. They are linear models, decision tree, and of course, one state-of-the-art machine learning model out of Microsoft Research called Explainable Boosting Machine, or EBM. If you haven't checked it out, you should check it out. It is very, very interpretable, yet accurate and efficient. So that's one collection of interpretability techniques for tabular data that we have there. Also, under Interpret, we have collected all the state-of-the-art basically black box explainers, interpretability techniques that can explain any black box model. What they need is the input features and the predictions. They do not care what's happening inside the model. They use a bunch of approximations on top to infer how the model has sort of played the game on top of these features in order to come with that predictions. So that's Interpret. If I want to put it short, a collection of interpretable models or black box interpretability techniques for models trained on tabular data. Now, another repo that we have underneath the Interpret ML organization under GitHub is Interpret-text. We learned a lot about the need for expanding this repository to include text scenarios. So our very first attempt was with text classification. So exactly the scenario that William mentioned about basically classifying maybe an email to be spam or not spam. What words contributed to this prediction of spam? So that text classification scenario was our initial scenario that we started with, and that's where you find 3 different interpretability techniques under Interpret-text. And then the other one is what we call DICE, or diverse counterfactual examples. And that is really, really helpful for understanding and debugging your model. So what it says is, show me the similar data points with different outcomes. So Marnouche's loan has got rejected. Who is the closest person to Marnouche who has got approval on his or her loan? It might be that, oh, Amy is the closest person to Marnouche, same age, same marital status, same salary, everything the same. Just her loan, student loan is 10K less than Marnouche. That's why she has got approved. And then using these counterfactual points, you can really see whether your model's decisions make sense. Of course, if my counterfactual is someone the exact same feature set as me, just gender flipped to male, then you know that there's a sort of a fairness issue that you need to go and investigate with Fairlearn, for instance. So it's like a red flag to you. So yeah, these are the multiple repos. Now, in near future, we have also interpretability for computer vision on our radar, and we really want to expand our repository to include better debugging and error analysis tools.
Nice. I actually have, I think, quite an interesting question from the audience, and that kind of, I think, Manoush, I think you'll want to comment on this one possibly first, but feel free to jump in, everyone. What is the likelihood of introducing unfairness through actually tweaking your model and introducing fairness in that sense? Maybe more unfairness. I don't even know if that's a thing, but is that something that you're worried about, or is there a way? Will this tooling help us to clarify whether we're doing that or not?
Yeah, so basically with all of these techniques, your model can behave unfairly. So there is very difficult with interpretability toolkit to really understand that fairness aspect of it. But of course, we have Fairlearn there in order to bring a lot more understanding of, okay, this change that I had happening to my model. Now take the outcome of the new model to Fairlearn assessment phase and try to understand how that impacted the predictions for different demographics, for different groups of people, say females versus male versus people of non-binary gender. So none of these toolkits is like magic for you to understand, exactly uncover everything, but combination of interpretability and combination of Fairlearn with, of course, domain knowledge and context can really help you at least investigate and bring a lot more understanding around your model. I know that Hannah has a lot of thoughts there too.
Yeah, maybe I can just jump in there just to say a couple of things. I think you more or less covered it, Manoush. I guess the only thing I want to flag is that when you're working with any machine learning model, it's of course entirely possible to make decisions that are well-intentioned and intended to reduce things like unfairness, but that might actually not help. And I think Willem's example of removing features like gender or race or age, these kinds of features from your data set before training your model, with the idea being, okay, this will get rid of unfairness, this is, then I'll be good to go, is kind of a perfect example. Even with those kinds of modifications, of course, models can behave unfairly, in large part because there are still signals about these kinds of things in other features as well. And so that's why we thought it was so important to have something like the Fairlearn assessment dashboard. That way people really can say, okay, look, I think I've done something that's going to reduce unfairness, but did it actually reduce unfairness according to these metrics? The other thing I want to flag is that there's many different fairness metrics that you can assess your model with in that Fairlearn dashboard. And that's really important because these models all capture different aspects of fairness and unfairness. Fairness is this fundamentally societal concept, and there's a lot of disagreement about what it might mean for a model to behave unfairly. Does it mean, for example, that the error rates should be exactly the same for different groups? Or perhaps does it mean something else? One of the things about Fairlearn is that we do have all of these different fairness metrics in there so that people can explore different ones and sort of say, really, how is my model behaving as a whole?
I love that. I love that breakdown of kind of like interpretML and then Fairlearn. Here's the different ways that we can consider, are we building fair models? Is there something that I need to know, something that I need to do? So I guess a call to action here is just, go read those docs, get immersed in what's going on with those dashboards and those interpretability kits. Because for anyone building these models, I mean, I guess it's innate in data science. It's kind of a skill that data scientists have of, digging in and interpreting what's going on in the data. I sometimes make the joke, I'm like the Sherlock Holmes of a data problem, trying to like sift it down, like figure it out, infer things, all of that kind of stuff. So I love that you've really lined it up nicely, kind of splitting up the two different things. And then Willem, can I go to you for a minute? So you've had a chance to look at the tech. Where do you see this being used in your day-to-day job? Is this something you're like, gotta get on it straight away?
So yeah, that's a good question. So right now, customers are getting started with ML Ops. So they're starting to use Azure Machine Learning Service and similar tools to actually make sure that they have a reproducible model. That's one of the other problems that we still have in the field, that we build a model and then we change the data and then we can't reproduce the results that we had before. So that's what's happening right now. And what I see happening in the near future is that people start to wonder, why should I trust my AI model? And Azure Machine Learning Service in combination with InterpretML is going to help people to understand, why am I getting this particular prediction? And might there be a feature that's extra heavy in this prediction that might indicate unfairness? And then you can start to use tools like Azure Notebooks in combination with a Fair Learn dashboard to discover what is the unfairness in my model. Right now, Fair Learn is mostly a debugging tool for me as a data scientist and a machine learning engineer to take a look, what's actually going on in my model? Why is it behaving this in this weird way? So I think the combination of ML Ops on the one hand and then these tools on the other hand will only make things better for the near future.
Fantastic. And I know if you can just put your other hat on for a second there, Willem, or your community hat, is this going to be top of mind for some of your next community, global AI communities, virtual tours, all of the amazing stuff that you do?
Yeah, so we've got a virtual tour planned on June 9. During that tour, we're going to explain more about Fair Learn, about all the other tools that we've explored with the community. And I've got a number of other things happening soon, mostly online, of course, because of the corona pandemic that's happening around us. But sure, yeah, a lot of people are interested in these new tools. And I've got a lot of questions from people. What does it mean to be fair? What do you think about ethics in AI? So there's sure a lot of stuff happening in the community.
Fantastic. And we have about a minute left on this panel. So if I can do a quick fire round, 10 seconds each or something, what's the key takeaway that you want people to take away for responsible machine learning? Let's pick one. Manoush.
I just want to really promote that let's move away from treating machine learning models as black box. InterpretML and Fair Learn all started with the goal of bringing a community around all these toolkits and helping co-developing it together. So definitely check us out and send us GitHub issues, sign up for contributing, and we'll be super happy to grow this community.
Fantastic. Hannah, 10 seconds. Can you do it?
Oh, right. Yeah, I think the main thing I want people to take away from this is that this is a complicated space that engages with broader societal issues. And as a result, software tools are not going to be a single one-size-fits-all solution. You will need to sort of engage with these issues and learn more about them. But we're starting to see a lot more resources out there to help developers really navigate that space and really understand it. So,
fantastic.
Yeah.
I'm so sorry we have a hard stop on this session. Thank you, everyone. For more on how we can engage in responsible machine learning, check out aka.ms, msbuild-responsibleml. Next up, a conversation that's sure to inspire the technology in all of us. It's our third digital breakout of the day. This time, Scott Hanselman, Luann Murphy, who are inspiring next-gen code with Make Code. Go take a look.
A little bit of sleep and